All right. So, Franklin, do you have any questions at the moment? Or are you good? Any questions about the classwork or anything?
For now, not yet.
All right.
No.
Sounds good. Sounds good. All right. So I'm just gonna jump into the lesson because we are running behind today, which I apologize about. I'm so sorry. All right. This is gonna be a good one for today. So I just want to start off with a little blast from the past real quick. All right. Boom. So we spoke about this before. This was exponents, right? So if I have -9 squared, right? Do you remember what that answer is? All right, so that answer is 81, right? And the reason why is because -9 squared, we remember, is the same thing as -9 times -9. And we call that just a positive 81, right? That's for A. Let's go for B. For B, I have a -9 squared, right? And the answer
So
is
it'll be negative 81.
correct, -81, right? Because we remember that this is -1 times 9 times 9, right? So -81. Let's look at C. So for C, I have okay, I'm good. I have -9 to the third power. All right. So we know that -9 to the third power is going to be what? -9 times -9 times -9, right? Right? Going straight across, -9 times -9, we know is a positive 81 times -9. That's going to give us a negative, and I'm not sure what that answer is. Let's look it up. 81 times 9. What's that? 729, right? And that's our answer. Is there any questions on this? Make sense? All right, let's keep it moving. Let's keep it moving. All right, we're taking it way back right now with this question, but I feel like we can handle it. Not too bad, right? So I want to round 3.846 to the nearest hundredth place, right? The nearest hundredth place, right? So we remember that the hundredth place is where, right? That's right. It's where the four is, right? That's the hundredth place, right? So if I want to round to the nearest hundredth, I have to look at the thousands place, this one. And if that number is five or bigger, five or greater, then I round up the hundredths place. In this case, it is, we have six. So what's my answer? 3.85. And then that's it. Is there any questions on this? No? All right, let's keep it moving.
No. No.
All right. All right, we throwing it back a little bit with this one as well. All right, so I have x to the third power times x to the third power. Whenever I multiply exponents, right, what do I do with the powers? Remember?
From the paper, yeah, I don't know.
So I'm looking at A. X to the third times x to the third. What do we do with those powers? without multiplying them. What do I do?
Don't you put them in the both sides in the bottom?
Kind of. So I'm gonna have a single x. And what am I gonna do with the powers?
You could multiply them or put them in the together.
Oh, it's not multiply, it's actually add them.
My bad, adding.
All right, so it's gonna be 3 plus 3, which is gonna become what? X to the 6th power. All right. Let's try B. So I have y squared times y squared times y squared. This is the same thing. So we already know this is going to become what? Y to the 2 plus 2 plus 2 power.
It'll be y over 6 again,
Very good.
because we just multiplying the 2, right?
Exactly, exactly. That was well done. Well done. Let's do another one. And I'm gonna do C. So for C, I have Z to the third times Z to the third times Z to the third times Z to the third. So I have 4 Z to the thirds. We know that this is going to become Z to the 3 plus 3 plus 3 plus 3 power. Call it a day. This is going to be Z to the what?
The 12.
Good, 12, right? And then that's it.
Okay.
That's it. That's how we simplify these.
Yeah.
Simplify exponents. So for today's lesson, I want to start off with a little bit of terminology and vocabulary. So we're going to start off a little simple. So what we're going to be doing, we're going to be simplifying expressions with roots, right? So in the beginning, right, we briefly looked at square roots, right? Remember that when a real number n is multiplied by itself, we write n squared and write it as n squared. This number is called the square of n, and n is called the square roots. For example, 13 squared is read 13 squared. 169 is called the square of 13, since 13 squared is equal to 169. 13 is the square root of 169. Right?
Yeah.
Oops, sorry about that. Right? Both of these are inverses of each other. So the square, hold on one second. There we go. So the square and the square root of a number. Square. If n squared is equal to m, then m is the square of n. Square root, if n squared is equal to m, then n is the square root of m. Right?
All right.
Mm-hmm.
Uh,
Got you. So notice negative 13 squared is equal to 169. So negative 13 is also a square root of 169. Therefore, both 13 and negative 13 are square roots of 169. So every positive number has two square roots, one positive and one negative. What if we only wanted the positive square root of a positive number? We use a radical sign and write the square root of m, which denotes the positive square root of m. The positive square root is also called the principal square root. This symbol, as well as other this symbol, as well as other radicals to be introduced later, are grouping symbols, right? So we always use the radical sign for the square root of zero because zero squared is equal to zero. The square root of zero is equal to zero. So notice that zero has only one square root.
Okay, one question.
Sure, go ahead.
So you're saying that zero, we're gonna only concentrate more on the zeros for there?
No, no, no. Just giving you that information in case you see it. Yeah,
Oh, okay.
you just will know what to do.
Okay.
All right, so let's talk about square root notation. So the square root of m is read the square root of m. If n squared is equal to m, then n is equal to the square root of m for n greater than or equal to zero. So the radical sign, right? That's a little the check mark looking house kind of thing. And the radicand is what's inside of that house, right? On the inside.
Okay.
So we know that every positive number has two square roots and the radical sign indicates the positive one. We write the square root of 169 is equal to 13. If we want to find the negative square root of a number, we place a negative in front of the radical sign. So for example, negative square root 169 is equal to negative 13. Let's try these out. So, what's the square root of 144? Right? We know that that's 12. Let's look at B. What's the negative square root of 289?
Negative 17?
Negative 17. I think that's right. Let me see. Yep. Is this equal to negative 17? Perfect, 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 perfect. All right. Give you one to try on your own. All right. Let you guys try one. All right. Let's take a look. Let's take a look. 1 second. Yep, -8. Very good. So we have A, And we're gonna have -8 here. Perfect, perfect, perfect. How about B? What do we think for B? Square root of 225.
For that one, I'll be totally honest, I'm not that sure. Like I'm calculating it, it's
Mhm.
not like it's not coming out as I think.
Feel like it's 15.
Maybe. I mean I have a lot of numbers coming out and every time I press.
Yep, 15.
Okay.
That's it. So in your calculator, if you were to do it, is second square root, and then you just write the number, and that's it.
Okay.
Mhm. So can we simplify the square root of -49? Right? Is there a number whose square is -49? Right? So you're looking for some number squared equal to -49. Any positive number squared is positive. Any negative number squared is positive. There is no real number equal to the square root of -49. So the square root of a negative number is not real, right? The square root of a negative number is not real. Let's say I have this question right here. They're asking me what's the square root of -196, right? Your answer for this simply is A is not real. B, on the other hand, this is what? Negative square root 64. This is just going to be -8. And that's it.
Wait, one question. How you what's the difference between those two? I mean I know that a negative is outside and the other one's inside, but how do you work that?
So if the negative is on the inside, just all you need to write is that the answer is not real or it doesn't exist or something, right? But if the negative is on the
Okay.
outside, it exists and then you have to simplify the radical.
Okay.
Mhm. Here, you guys try.
Um,
Mhm.
I put in the chat the information.
Well, let me check. Perfect, not real, and negative, not 8, we're close. So A, oops, sorry. A, not real. B, -9, right? 81 is 9 times 9, right? And that's that. Let's keep it moving. So I want to do some vocabulary real quick. Well, you guys are not confused in your other classes. All right, so let's review some vocabulary first. So we write n squared as, and we say n squared. We write n cubed, and we say n cubed, and then we say n to the fourth power, n to the fifth power. The term squared and cube comes from the formulas for the area of a square and the volume of a cube. All right. Excuse me. Now I want to give you guys a chart. Let's review it real quick. Let's say I have the numbers from starting from 1 all the way down to 5. So 1, 2, 3, 4, 5, include x and x squared. All right. So the square of those numbers would be 1, 4, 9, 16, 25, x squared, and x to the fourth. All right. Excuse me. The cube of those numbers would be 1, 8, 27, 64, 125, x cubed, y to the sixth power, so on and so forth, right? If I have the negative numbers, -1, 2, -3, -4, -5, the square of the negative numbers are 1, 4, 9, 16, 25. The cube of those numbers are -1, -8, 27, -64, -125. etc. All right. Excuse me. All right, notice the signs in the table. All powers of positive numbers are positive, of course, but when we have a negative number, the even powers are positive and the odd powers are negative. So we'll copy the row of the powers of -2 to help, right? See this. So if n is -2, when I square, the -2 becomes 4. When I cube the -2, however, it becomes -8. When I raise it to the fourth power, it becomes 16. When I raise it to the fifth power, it becomes -32. So even powers will give you a positive result. Negative powers will give you odd powers, I meant to say, excuse me, will give you a negative result. Okay. Something good to know. Now I'm going to get into a little bit of the formula. This is found on your formula sheet, you guys. You can check this out. So the nth root of a number, if b to the n is equal to a, then b is an nth root of a. The principal nth root of a is written as the nth root of a. N is called the index of the radical, right? So once again, n is called the index of the radical. Alright, just like we use the word cubed for b to the third power, we use the term cube roots for the cube root of a. We can refer to in this figure to help us find higher roots. So 4 to the third power is equal to 64. 3 to the fourth power is equal to 81. Negative 2 to the fifth power is equal to negative 32. And the square root of 64, we know gives us back 4. The square root of 81 gives us back 3. And the fifth root of negative 32 will give you back negative 2. Could we have an even root of a negative number? We know that the square root of a negative number is not real, is not a real number. So the same is true for any even root. So even roots of negative numbers are not real numbers. Odd roots of positive numbers are real numbers. Let's look at some properties of the nth root of a. So properties of the nth root of a. When n is an even number and a is greater than or equal to 0, then the nth root of a is a real number. When a is less than 0, then the nth root of a is not a real number. When n is an odd number, the nth root of a is a real number for all values of a. You guys try. All right, let you guys try that out. Let's take a look. So I want the cube root of 64. Excuse me, 64. All right. So then now I want the largest perfect cube that goes into 64. What do we think it is? Two. What is it? Think. Another way you can do this is use your tree. You know that this is 8 times 8. Break this down. 2, 2, 4, 4. 2, 2, 2. Mhm. Okay. It's 2 times 2. All right. So now let me count my twos. I have one, two, three, four, five twos, six twos, right? So I know that cube root of 64 becomes 6 ooh, 6 to the 1, 2, 3, 4, 5 power. All right. This I can break up into cube root of 6 to the third times 6 to the second, bringing out the 6 and then having cube root of 6 to the second. This would be my answer. A little complicated, but not so bad. 81. We know that 81 is what? This is 3, right? And then C, you could probably tell what that's going to be 4, right? Good stuff. Actually, 2. 2. Sorry about that. Right. Want to jump into some more stuff real quick because of time. I feel like we get the gist of these. Okay. Use the product property to simplify radical expressions. So we will simplify radical expressions in a way similar to how we simplified fractions. A fraction is simplified if there are no common factors in the numerator and denominator. So to simplify a fraction, we look for common factors in the numerator and denominator. A radical expression, the nth root of a, is considered simplified if it has no factors of m to the n. So to simplify a radical expression, we look at any factor in the radicand that are powers of the index. All right. Let's talk about this just a little bit more. The simplified radical expression for real numbers a and n, excuse me, a and m, and n is greater than or equal to 2, the nth root of a is considered simplified if a has no factors of m raised to the n power. For example, the square root of 5 is considered simplified because there are no perfect square factors in 5. But the square root of 12 is not simplified because 12 has a perfect factor, square factor of 4. Similarly, the cube root of 4 is simplified because there's no perfect cube factor in 4. But the cube root of 24 is not simplified because it has a perfect factor, excuse me, perfect cube factor of 8. So to simplify radical expressions, we will also use some properties of roots. The properties we will use to simplify radical expressions are similar to the properties of exponents. We know that a times b to the n power is equal to a to the n times b to the n. The corresponding product property of roots says that the nth root of a times b is equal to the nth root of a times the nth root of b. All right? So similar rules, similar rules. All right. So we have the product property of n roots. If the nth root of a and the nth root of b are real numbers and n is greater than or equal to 2 is an integer, then the nth root of a times b is equal to the nth root of a times the nth root of b. And the nth root of a times the nth root of b is equal to the nth root of a times b. Okay, let's check this out. So we want to simplify square roots using the product property of roots, right? So I have a square root of 98, right? We have square root 98. Now, what I want to do, right, is I want to simplify this down, right? I know that for the perfect squares, right, I have 100, which is equal to 10 squared, right? I want to see get a perfect square that divides into 98. So I know 100 can't be it. So 10 squared is out. What about 81, which is equal to 9 squared, right? Can 81 go into 98 evenly, right? It doesn't, right? How about 8, which is 64, right? Does that go into 98 evenly? It doesn't, right? How about 49, which is 7 squared? Does that go into 98 evenly? Yes, it does. 98 could get broken down into what? Square roots 49 times square root 2, right? So now the square root of 49 is what? This would be 7 and then square root 2. This will be your final answer, right? That being said, let me let you guys try one. Something quick. I want to simplify this down. That's what my goal is. Look at your perfect squares, work backwards, right? Okay. Okay. It's a nice start. It's a good start. It's a good start. So let's look at this. So they want the square root of 48, right? So now, what do I know? I know that I have 49, which is equal to 7 squared, but 49 doesn't go into that. Let's go into the next one right underneath, 36, which is 6 squared. Does 36 go into 48 evenly? No. How about 25, which we know is 5 squared? Does that go into 48 evenly? No. How about 16, which is 4 squared? Does that go into 48 evenly? Yes, it does, right? Because if I do, right, 48 divided by, yeah, 48 divided by 16, like that, right? We know that that's what? 3, right? And 3 times 16 is 48, as you can see, right? So now I can break this up into what? Square root 16 times square root 3. And the square root of 16 is simply just 4. And then we leave back the square root of 3. That right there is my final answer. And that's how we work that out. All right. Let's talk a little bit more. So notice, right? In the previous example that we simplified that the simplified form of the square root of 98 is 7 square root 2, which is the product of an integer and a square root. We always write the integer in front of the square root. Be careful to write your integer so that it is not confused with the index. The expression 7 square root 2 is very different from the from the seventh root of 2. All right. So just to emphasize this again, right? 7 square root 2 is not the same thing, right? It's not equal to the seventh root of 2. Very different, right? So make sure you make your numbers that are in front of your index large so that we can tell what they are. Okay? Before we continue, let me give you guys a little bit of notes. You guys can write this down. So this is how to simplify a radical expression using the product property. So step one, find the largest factor in the radicand that is a perfect power of the index, right? Rewrite the radicand as a product of two factors using the factor. Step two, use the product rule to rewrite the radical as the product of two radicals. And step three, simplify the roots of the perfect power. All right. There's a little bit of notes with that. Alright. Let's say, for example, I want to do the square roots of 500, right? So A is square root 500. Now I know that there's a perfect square that goes into 500, right? That's going to be what? Square root 100 times the square root of 5. And the square root of 100 is what? That's 10. And then we're left back with the square root of 5. All right? That's one way you could do it if you know the perfect square that goes into it. Let's say, I'm going to give you guys an example. Let's say, for like number 3, for example, I don't know what goes in. I don't know what the perfect cube that goes into 16 is 8, but I don't know what it is, right? What you could do is you can take the radicand and break it down into its prime factors. I'm showing you guys a different way now, right? 16 gets broken down into 8 times 2, right? 2 is prime. And you can break down 8 into 4 times 2, 2 is prime. And then break down the 4 into 2 times 2, where 2 is prime, right? What you do after that is you count, right? Let's count how many twos we have. 1, 2, 3, 4, right? So watch what I'm going to do with B now, right? They want the cube root of 16. I'm going to break down the 16 very simply into the cube root of 2 raised to the fourth power. Why the fourth power? Because I have 1, 2, 3, 4 twos, right? Now, remember, we want to break this up into a power that is divisible by the index and one that isn't. So, cube root of 2 to the third, right, is divisible by the index times cube root of 2 to the first, just like that, right? The cube root of 2 to the third will cancel out, leaving back just a big 2 with the cube root of 2 to the first. This is my final answer. This is another way that you can do it, right? If you don't know what the perfect index is, I'm going to do that same way on number 4, right? I mean C, excuse me, on letter C. I'm sorry, letter C, right? So I want to know what the fourth root of 243 is, all right? So I don't know what the perfect fourth root of 243 is, right? So what am I going to do? I'm going to break this up, 243 into its basic prime factors, right? Now, let's see. 2 plus 4 is 6. 6 plus 3 is 9. 9 is divisible by 3, so I know that 3 goes into this, right? I'm going to cheat. I'm going to use the calculator real quick. 243 divided by 3, what is that? That is 81. So I have 3. 3 is prime, and then I have 81. And from there, I can finish this off, right? 81 we know is 9 and 9, right? And we know that 9 is 3. 3 is prime, 3. 3 is prime, 3. 3 is prime, and 3. 3 is prime. So I have what? 1, 2, 3, 4, 5 threes, right? So I can rewrite this fourth root of 243 as what? The fourth root of 3 raised to the fifth power. And remember, I want to break this up so that I have a perfect fourth root, right? A perfect power that is divisible by the index. In this case, I'm going to have the fourth root of 3 to the fourth power times the fourth root of 3 to the first power, right? The fourth root and the fourth power will cancel out, leaving back just the big 3. And then I'm left with the fourth root of 3 to the 1. And boom, that's my final answer. Any questions on this? Anybody?
No, not for now.
Not yet? All right. Let
Uh,
me just let you
excuse me.
guys try one. Go ahead.
I have to go to class right now. Sorry.
No problem. Go ahead. No problem. I'll catch you next time.
Okay. Thank you.
You're welcome. You're welcome. All right, I'm gonna let you guys try this. You guys should have enough information to do all your homework thus far. All right. I'm just gonna take a look at it. Homework has been posted. You know, once again, I'm sorry, everybody, for the delay today. I had a lot of technical difficulties on my end. I'm very, very sorry about that. The recording will be posted as usual, right? For both those that are live in class and those that didn't make it to class, I understand, all right? Just take a look at this real quick. Make sure that we're good. As you can see, like I said in the beginning, homework is going to start to taper off a little bit. You know, we're not getting that big amount of homework that we used to get anymore, right? So it's going to be a little bit better. All right, this is good. Yeah. You guys should be good for the homework. All right. Hardest topic on your homework is what we're doing right now. finding that perfect whatever that goes into whatever question it is that you got. That's going to be the challenge, but we're going to meet that challenge, right? It's not that bad. Mhm. Today is Thursday, so I hope everybody that was going to take part in pantry did. Today was the pantry. As far as the test is concerned, I have not graded a test as yet, so I don't have any comments for you today. Um, I'm my goal is to get them graded and possibly handed back to you by tomorrow, excuse me, by Tuesday. Sorry about that. Okay. Um, that's about it. So let's start going over these real quick. All right. A is fairly simple, right? I have square root 288. I know that I could break this up into square root 144 and square root 2, and the square root of 144 is simply just 12. And then we have square root of 2. That's my answer. That's not so bad, right? Not so bad. However, let's look at B. B is a little bit harder, right? I want to know what the cube root of 81 is, but I have to find that perfect cube. I don't know what that is, right? So I'm going to start off with 81. Just break it down to the basic prime factors. 9 times 9. And then break this down. This is 3, 3, 3, and 3. So I have 3 to the 1, 2, 3, 4 power. So the cube root of 81 gets broken down into the cube root of 3 to the 4th power. Let's break this up, right, into a power that is divisible by the index, in this case, 3 to the 3rd power, times the cube root of 3 to the 1 power, right? Now the cube root of 3, excuse me, the cube root of 3 to the 3rd power will cancel out, leaving back just a big 3. And then we're going to have the cube root of 3. And this will be our final answer, right? Not too bad, not too bad, not too bad. All right, let's move on. So for C, right? For C, we want the 4th root of 64, right? But we don't know what the perfect 4th root is that goes into 64. So let's just work it out, right? We know that 64 is very simply just 8 times 8. Let's break down the 8 times 8. That's 2 times 4. 2 is prime. And then this is going to be 2 times 4, where 2 is prime. And then the 4 is 2 times 2, and 2's are prime. And then this is 2 times 2, where 2's are prime. I have 1, 2, 3, 4, 5, 6 2's, right? So I could rewrite the 4th root of 64 as the 4th root of 2 to the 6th power. And then remember, I want to pull out a perfect fourth, right? Or a power that's divisible by the index. So this is going to become the 4th root of 2 to the 4th power times the 4th root of 2 to the 2nd, right? Now the 4th root and the 4 will cancel out, leaving back a giant 2. And then we're going to be left with the 4th root of 2 to the 2nd, or let me write it again. 2 is going to be the 4th root of 4. Boom. Now be my final answer. Any questions on this? Anyone? All right. And that's it for today. Have a little bit of an easy day with a late start. Apologize for that in the beginning. If you guys have any questions or anything, shoot me an email. All right, I'm gonna stop it for today. Please reach out if anything. All right, I'm gonna have this posted not too long from now, maybe about an hour or so, depending on the internet. All right, so have a good night, have a great weekend. Talk to you guys next time.